We are back. Oh. Would you like to join Sector 12? Sure. I guess we'll be at war with these four or something. Offline, we generated 4 million. Hacknet nodes, 47 million. And 0 reputation. I wonder if... Okay, no. All right, they're giving us our request again. I guess this must have been going on in the background, right? I guess it's just not part of the summary screen. Because now we're at 100% chance, which means we were like training the skills or something. And we have like way more money than summary said. Pretty sure. Infiltrate. Sure, let's try it. Is it Joe's guns? Ooh, still only 75. I guess because we need strength and dex. Let's go to the super gym. Some strength. Is that the best gym? There's also like you can fly around, right? So we could check out some new place like Avum. Cost 200 grand. Inflation's crazy. I guess we can join this faction as well. It's like enemies with the same one. I guess it's the Americas versus the rest. Join. Ooh, new map. Police headquarters. Neat. Wait, how? Infiltrate. I'm assuming we won't be able to infiltrate anything. There's another gym. Seems to be like... How are we even at that gym if we technically took a flight? Oh well. It's like the same. It looks worse. Oh well. We have a hospital. Ooh, Crush Fitness. That's what I'm talking about. This looks even worse, right? Assuming price is quality. Go back. Clark Inc. Galactic Cyber Systems. Curious, are we like... It's the same servers here, right? It doesn't matter because it's the internet. But I guess we like relocated where we live. Cancel. Curious. E-Corp. Oops. Right, there's like 2 stores. Basically doing the same thing. Cool. They have their own slums. Very nice. Stock exchange. Ooh, casino. It's exciting. Okay, I'm assuming we can't infiltrate basically anything. Let's change to doing some defense. Yeah, GG. Okay, well, we can gamble. Let's play coin flip. Ooh. Wow. Oh, do we like, I guess we gotta bet something? Can we bet like 1,000,000? Is that not how it works? Weird. Slots. I guess you probably have to type it out. Spin. Okay. This feels very dumb. Like, what's the payout? Exactly like real life. Okay, we gotta pay or play till we win at least once just to see. Okay, fine. What else? Roulette. Well, odds or evens, or I guess black. Isn't that like the same thing, red and black? Oh, we won $1,000,000. Oh, and I think we got invited to the Slum Snakes. Cool. Slum Snakes rule. Perform assignments, field missions, security work, donations. Okay. I think these are like gangstas, I guess. Alright. Let's play some blackjack. Wow. 13. Okay. We lost. 5 or 15. King. Face cards are 10, right? Be sure we hit. Okay. This one 1,000,000. Yeah, let's bet 10 to get the hang of it, right? Okay, 18. Tie. Okay, well, instantly lost. Cool. And I guess we gotta hit. Not really. Stay. Okay, last time. Oh dear. I think we can stay, actually. Maybe he'll get like 2 10s or something. Okay, actually, last time. Hit. All right, enough of that. Uh, we tried the casino. Very good. Ah, yeah. Life lesson or something. Let's see. I guess we could travel. What happens if we travel to like here? Okay, I guess even though our faction is enemies, but, like, I wonder what that affects. Travel agency. Compute tech. Assuming these prices are just all the same. Jimmy's not as good. This is like a small map. Still nothing we can really infiltrate. Might have to go back to Sector 12. Yeah, there must be a way to code, like get every location or something, and then see requirements. Or just like find various things in the world. Okay, well, let's do that. Script. That went correctly. I guess we'll just call it infiltrate. And I also wanted to make like same thing, but um, finding contracts. Okay. So is there like location package or something? City is corporation. Maybe corporation, right? Because it's corporation info might tell us. Maybe not. This looks different. Search for. Okay, infiltration. Here we go. Oh, well, that's not much of a script. Well, there's the script. Yeah. Meh. Uh, Save. Run. Or, sort of like run with tail button, I guess. Name. Okay, so these are all the things. Can we do like new line? Yes, we can. It's kind of nicer. Cool. And maybe like what else is available? There must be like some sort of stats, right? Is that eye location? Oh, that's different. Okay, it looks like we still need to like kind of edit the data. Okay. Infiltrations. Yeah. The location, I guess. Cool. Yeah, good. Infiltration location. And that has difficulty, the location data, and the reward. Okay, so we probably just want to sort it by difficulty. Right. See. And then let's do that. So the locations, get their names. Put the names. Oh. Location name. Sure. Where is location name? Uh, this, I guess. Filtration location. Sorted locations. Kitchen.main. And we probably actually want the city as well. Maybe we want like... Oh, sorry. Yes, you are correct. Yeah. Let's see. Let me just do this. Sick. Looks great. So it looks like noodle bar is the easiest. How do we not find that last time? That makes sense. Because I guess it's probably like the servers, right? Servers more or less correspond to it. Okay, let's check out the noodle bar. Yes, we will perform espionage at the noodle bar. Okay, where is the noodle bar? Oh wait, was it in... Oh, it was in New Tokyo, that's why. Oopsies. I guess that makes sense. Here's Tokyo. Oh, and we got invitation. The Tian Di Hui. Okay, sure. Obey heaven and work righteously. Sure. Wow, this is like very small Tokyo, I guess. They made New Tokyo and they decided Tokyo was way too big. So let's make small Tokyo. Wow, there's an arcade. Megabyte Burner 2000. This machine is broken. Cool. Defcom. Is probably not hackable easily. Alright, it looks like this is the noodle bar. Why is everything question marks here? We could even be a waiter. I wonder why there's reputation for like working at the noodle bar. Like what does reputation get you? Very curious. Oh, you can eat noodles. You ate some noodles and feel refreshed. Is that like HP? Alright. It's time to infiltrate the noodle bar. I'm kind of concerned because it's still in the yellow range and it was absolute disaster when I tried it here. So, yeah. Okay, here we go. Arrow keys, spacebar. Type it backwards. Mining joystick. Okay. Remember all the mines. This. Oh shit. Cut the wires. Cut the wire number 6. Yellow. Shit. Oh my god. Dashboard. Station. Friendly. Oh. That was That was something. Infiltration successful. We can trade the confidential information for money or reputation. Okay, I mean, let's do it for our city. Represent our city. It's not really much money. It's like a game of blackjack. Would you like to join Shadows of Anarchy? Sure. Special faction. That's exciting. Government is ruled by the corporations that we have allowed to consume it to release the world from its shackles. The gods grant us their strength. Oh god. Oh god. I gotta infiltrate the noodle bar. Oh wow, sick. Don't have to type the square brackets in the bracket minigame. It's like, square brackets is the easy one. Well, I guess you can just hold down shift for brackets and squiggly brackets. So then you can just keep holding shift. I don't think we've seen this game. Bribe mini game. I don't know if we've seen that one. It just flips the words to normal. Amazing. Simple matching. Okay. So this one just shows you the game. Shows you mines. It's kind of cheap. I feel like at least the bracket one you still have to do something. The other ones are just like, you now win. Maybe this one is the way to go. Increase timer. Easier to infiltrate the noodle bar. Feel the strength. There's no gym in Tokyo. Come on. Come on, Tokyo. Oh, I'm damaged. Yeah, let's go to like, I feel like the North American gym's the best, right? Maybe we should verify that. Find gym. If this is actually possible. Maybe not. Okay, so there's... I guess we saw all the gyms, I think, right? And... Sure. Okay. Don't need to bother. Yeah, I don't think it... I think this is the best one, right? Weird. Funny if you could like script the gym. Let's see. It's right to record. Okay. What else? Oh yeah, I wanted to make a find contract script. Let's like let that run, and then maybe we can try noodles a couple more times and get that augment. After it's a little easier because that was hectic. Yeah, so let's find some contracts. Probably. You want to just get every server like we usually do? And we kind of, I guess for every server, we just want to get every single file everywhere, and then we'll filter for .cct, I think. I guess like it doesn't know the type. Okay. Like files. ls. Substring for the substring. Oops. Substring to search for in the file name. Okay, I mean, I guess we can just pass in .cct. And then we'll, oops, I guess we don't want to do that. Full files, save it. And then we'll do flower. Actually, be kind of nice to. It's just the names. Kind of nice to add the server name, right? Kind of like how we did with cities. Or host name. Here. Kind of nice to add typing here. It's cool, you can actually see it. But you can't open it. Or can you? Ooh. Whoa. No, it doesn't work. Alright. Undefined. Can I even do that? Maybe I have to do like. Let's see about that. Add. Speed. To do this. I guess we want this. Yes. Okay. And then here. Sense. If that makes sense. Is there really nothing? Is it .cct? Is that not? Maybe that doesn't count. Just try this. Okay, something's worked. Do I have to await this? Okay, there are contracts actually. Does this not work? Oh, it probably doesn't edit it in place. It just returns new array, yeah. nice. And then we should be able to search for CCP. Oops, what did I do? Okay. Cool. Why is this messed up? Oh, I printed both. Sick. All right. Here are some contracts. Pretty cool. Why don't we go to Noodles and do a contract then? Oh, actually, let's buy that. Auto link. Could actually, I guess we could buy more stuff. We should probably buy this too. And this too. IFTP. What else? Okay, let's buy HTTP as well. And that's probably enough for now. And let's run our nuke. So wait, actually we can do 3 ports. Is our nuke script support 3 ports? HTTP 3. I guess not. So we can toggle this up. I mean, honestly, we can just, there's no such thing as too secure. We can just implement the rest of the port methods, right? 1, 2, 3, as 3, 4, as HTTP, 5, as SQL, I don't know what it's called, I'm just gonna do that. I guess it's these names, it's fine. System. And then there's a code delay. Cool. And this is HTTP1, and this is SQL injection. All right, and that should just work. As we get more stuff, right? That seems like more stuff. Okay, one sec. And then load pack. Very nice. I think also someone gave us a quest to like backdoor this or something. Heart. What's up? Very nice. Okay. Anyways, let's go and go to Noodles. So we're gonna do a contract. Also, I guess what I'm curious is, can we copy a contract? What will it say? Alright, what if I just copy? My I see. Can I do this? I guess not. Probably same with SCP, right? Gotcha. Okay. So we can't copy it. That's fine. So we will run it, right? Proper two-coloring of a graph. You are attempting to solve a coding contract. You have 5 tries remaining. After this contract will self-destruct. Okay, let's just copy paste this into our let's call it two-color graph. Yes. And do that. Okay. Proper two-coloring of a graph. You are given the following data representing a graph. Oh dear. 6, 0, 4, 4, 5, 1, 3, 1, 2. Note that graph as used here refers to the field of graph theory and has no relation to statistics or plotting. First element of the data represents the number of vertices in the graph. Each vertex is a unique number between 0 and 5. I guess just in this example. The next element of the data represents the edges of the graph. 2 vertices UV in a graph are said to be adjacent if there exists an edge UV. Note that an edge UV is the same as an edge VU. As order does not matter, you must construct a two-coloring of the graph, meaning that you have to assign each vertex in the graph a color, either 0 or 1, such that no 2 adjacent vertices have the same color. Summate your answer in the form of an array where element I represents the color of vertex I. If it is impossible to construct a two-coloring of the graph, instead submit an empty array. Oh Lord. Let's see, 0 and 1 are the colors. I wonder if like 0, 0, 1, 1 is valid and 1, 1, 0, 0 is also valid as an answer. Yeah, this shit's crazy. So I guess like it's impossible if there's a triangle, basically. Because as soon as you assign 2 colors to 2 vertices, the third one would make it bad. You want me to just like run the program? Make the problem. Okay. I'll like make this. I mean, I just copy pasted it in, so I mean, I can do it manually. Maybe there is like, okay, we can do this. Never mind. Very nice. I don't know if that's that helpful though. Yeah. Ah. Hmm. Okay. So we need, like, it seems like we need to maybe detect triangles. Um, so imagine, it's fine. You know what a graph is, right? So imagine like one of the examples is this. And then the other example is like this. Right? And the idea is you're drawing, imagine you're making a map, right? And you have to, these are all different countries and they're all touching. They need to be different colors. So, but you only have two colors. You have 0 and 1 as the colors. So in this one, you can do it. You can be like, okay, 0, this one's 1, this one has to be 0, and then this one has to be 1. And then they're all happy. But in this one, it's like 0, 1, and then what do you color this one? It's touching both these. So this is impossible. So this, the answer is just blank. While in this one, the answer would be like 0, 1, whatever. Whatever like the node IDs are. Does that make sense? If first number on the array is odd, it fails. Which array? Oh, the input? Um, I don't think... No, that's not true. Because you could have this. And it's fine. First element is the number of vertices, otherwise known as nodes. And then the other pairs are like the edges. Hmm. Yes, I think order does matter because so you get the order. This is like the index of the node. So like 0. This is an edge between 0 and 2. So this would be like the color of 0, color of 1, color of 2, and color of 3. So there's only two colors. So it kind of, we can always color the very first node just 0. Because if there's an answer with like 0 as the first node, there's an opposite answer with 1, right, as the first node, and we just need like one valid answer. So it's kind of irrelevant. So we might as well start with 0. And then we can color adjacent nodes 1, and then keep traversing. Always, basically, we should always color adjacent nodes to the current our current location, the opposite color of our current location. And if we ever see a node that we've seen before and it already has a color, it's okay if it's the color that we were going to color it, but if it's the color, the opposite color of what we were going to color it, then we know shit is busted, and we can return empty array. I think that makes sense in my head. Okay, we could we like don't really even need to build a graph data structure or traverse it, I think, technically. Because we have the edges. So we could just loop over the edges, and then we just have we just have an array. Right? It seems like kind of a dumb solution, but basically, like, we just keep looping over this edge thing, and then, like, oh, if we're at 0, we select the ones with 0, color 2 and 3. Actually, I guess we do need to kind of build the graph. So then we want to go to like 2 next. But we can still make use of this, I think. I need to build the graph. Maybe we can make like a node class, I guess. Like let's say we made node class and then add like neighbors around adjacent nodes. Color. I guess like here. Let's do this one. So example. Like nodes. You can just have a list of nodes and then initialize them. Okay, keep forgetting. Yeah. Cool. I mean, that's fine. So we'll make a bunch of kind of like empty nodes to start with, and then we can loop over the edges. I guess. And we want to connect, so there'll be like left and right. Equals like edges and 0, and then left and right doesn't actually matter, but just so we can like select them. And then I guess let's say index. So left index will be like 0, right index will be 2. So we want to connect them. Do like nodes at, we'll select the left node, and we can add the right node to its adjacent nodes, right? Keep forgetting the function. Let's restart. Well, is this just going to be an integer array, or is it going to be nodes? That's the question. I'm probably fine with just indices. Fancy. Okay, so the left node, okay, so node indices equals this combined with just the right index, I guess, right? And then we want to do the exact same thing. Okay, so I'll just copy this. That'll be the butt. So the right index, this node indices is equal to the right indexes adjacent node indices with the left index. That makes sense. So 0 and 2. Thanks, NS Watermelon, for the follow. Yeah, so we connected them. We got 0 node. It's now connected to whatever it was, which was empty. We added 2 to it. And then we also took 2 and added 0 to it. So I think that's fine. Okay, and then we can 0 should start as 0 color. Or I guess like, yeah, I mean, yeah, that should be like the initial condition so that we know what to sort of do next. And then we can do like, and then like we sort of want to recursively keep traveling, coloring the connected nodes. I think we can just do like a BFS or something. So, because we don't want to go to the same, we don't need to process the same node more than once, so we'll just have a set for that. And then we have like our queue thing that we will add to as we traverse the graph. And then this will actually be a while loop. Yeah, so we don't need a selected node. Maybe we do. Let's hold our horses. So we'll start with the selected node so that the queue's not empty. While queue dot length is more than 0. Okay, so the selected node equals queue dot shift grabs the first element and returns it. So that'll grab this guy. Okay, I think we also need like current color. It's getting wild. And this will be like okay. And then selected node. I guess as soon as we check like if selected color will be like what we paint it, right? If the selected node's color is not null, and selected node's color is also not equal to the current color. And basically it means we're trying to paint it the wrong color, which means basically we return, right? Return empty array as the answer. Try printing. So no solution. Okay. Otherwise, if null, we can paint it. We don't really even need the if check, I guess, but it's fine. This is not gonna work. I was kind of thinking like, okay, we have a queue, and then every time we pick an element from the queue, we just flip the color, but that's not true. Because like, if there's two connections, that means the next two nodes in the queue would have to be the other color. Like you have to actually trigger the color swap. So I think when we're adding to the queue, we need to keep track of like the color of the parent. Like of whoever added it to the queue. Either the color of the parent, or if we want to go the opposite way, we can keep track of the expected color of the children. That would also work. So then essentially the queue becomes something like this. It'll be like mini arrays where I think I like expected color better. That feels easier to reason. So like if we're doing something like this, we would like grab the first node and then we would add its children. And let's say children is like ID 1, and the other child, or neighbor, I guess, is ID 2. Then these are expected to be this. And then when we process this guy, we would add its children here. It's like, I don't know, 3, and then go back to 0. So it's like index expected color. Kind of wish I studied more graphs or something. Maybe there's just like some dirty solution here. Oh well. This feels like plausible though. Okay, so then instead we're doing this, right? We have our, or it's not even index. It's I guess we could do index. Yeah, maybe we can just work with indexes. We don't need the. Sure, why don't we do that? Okay, so I don't know, call it like element. It's q.shift, and select the node equals element of 0, which is a number. I gotta actually grab it. Node array. Like that. And then expected color equals element other number. And if selected node dot color is not null, select node dot color does not equal to expected color, then we've tried to paint the wrong color. And if the selected node's color is null, we can set the color to the expected color. And then we should okay, now we got to add all of its neighbors to the queue. No dot adjacent node indices dot blank. Plus. I've been coding so much without checking anything, and then I'm gonna run it, and it's just gonna be blank. A good time. Okay, so like x equals so we grab neighbor. We call this scene node. Okay, if the index or scene indices are as the index, or basically if it doesn't have it, we can add it there, and q equals q.cat, and we add our new thing, which is the index, and can I do like 1 modulo 1 or something? That's fine. You expect color. You just toggle between 0 and 1. Like, I could do like... Oh. True. Right, if it's 1... No. Sorry, 1 minus expect. Like if the old one is 0, it becomes 1. If the old one was 1, it becomes 0. True. Okay. Okay. Okay, where are we? What is going on? So if we've processed everything and we didn't hit this, that means there is an answer. And I guess now all we have to do is loop over our nodes and pick out the color. Answer and get nodes at I dot color. Is that the format of the answer? Okay. Oh, God. Cool. 53. No, it's not. Element is not defined. Sure. Color is not defined. Sure. Uh oh. This is spookier. Okay, let's print out element. Style. UI dot tail. Okay, element 0, 0, perfect. And then for some reason, the next element was just 2. That is bad. Oh, because this probably like unwraps it or something. I do like add, append. Let's check JS array now. Push, that's what it is. No, that doesn't seem right. Maybe it doesn't like it because this is an array. Let's try it. Oh, it does work. Okay. Maybe concat like unwraps things in an undesirable way. Okay. We got an answer. It could be correct. Nobody knows. It matches the example. That's exciting. Do this. Fuck. Okay. Zero, 1, 1. Okay, feels close though. Feels close. So element 0, 0. We got our node. We have our expected color. We color it 0. Maybe create a set of elements. Oh, shoot. We went back to 0, 0. I think, well, that's one problem. I guess we want to initialize this with like, no. Yeah. Like, I guess we initialize this with like the 0 node. But that doesn't really, well, that solves this problem, but it's still busted. Okay, so first element, expected 0, that's fine. It's connected to 1 and 2. So these should be processed next. And 1 should be given color 1, and 2 should be given also color 1. I see. I guess like we're coloring them on the initial traversal, but then maybe like we just stop. Because we're on element 2, and then element 2 is connected to element 1. Like we should at least check that they're not the same color of the children so far. I think that's what it is. So even though we're not adding new children to our set or like to the queue, we want to compare the current selected node's colors to all of its children that are not null. So we can just do that. Well, okay, I guess like here. Um, like, so the current logic is like we go through the graph and we keep painting things, right? And we return like an empty array, which is like the fail case, right? We return the empty array if, as we're painting stuff in the graph, we repaint things in the wrong color, right? But what if we, pretty much any graph we traverse, since we're like, we never repeat, like we'll never paint it the wrong color because like we only ever go through the graph once ever. So like, I guess we could theoretically just reuse our program and just run it again Well, I mean, that won't work because it'll just be the same. It's kind of like deterministic colors. But what we actually have to do is as we paint, we should also check the color of its children. Does that make sense? Or did I just make it more confusing? Okay. Yeah. Because like we can't just check its own color. Like that is one way. That will like catch some things maybe. But really we need to check like its neighbors. So probably we do that here. Looping through neighbors. And then if the like if the neighbor color is the same as the selected node dot color, then we should early return. Found neighbor with same color. Okay, well that works. Let's double check that this also works. Still works, 0011. So the two test cases work. Pretty sick. And I feel like the logic makes sense. Okay, let's try the actual puzzle. What is the actual puzzle? Oh, this is the actual puzzle. Pray. Oh dear. Oh god. What the hell? Uh... 0, 0, 0, 0, 1, 0. Okay, what is this graph? Is it because it's like not even connected or something? Are you laughing, dude? 0 to 4, 4 to 5, and then 1 to 3 and 1 to 2. Yeah, this is like it's 2 graphs. Oh my god. Yeah, so we traversed we basically traversed one of the graphs and colored it. And now do we care? Like, can't we just... We could just have everything... Oh, our queue has like an expected color thing. Oh my god. Like, I guess at the end we could re-add to the queue if there's any null things. It'd be nice to just identify, like, separate graphs right away. Yeah. Like it'd be nice to just know that there's two starting points in this like example. This is, yeah, kind of nice. It's like obvious question to debug, but harder to code. I guess, well, we have the length for one. Okay, at the very end of the while loop, if u is empty, right? We can push the first element that is null inside our answer. What is answer? Just colors. Sorry, nodes. So, and basically if n.color is null, there. We can push how can I get the ID? I give them an ID. How do I get the index? I don't think. Okay, find index. Great. Cool. So n.color is null. Index. And then we push the null node index. And we can just start with 0, right? Because it's like a separate graph, maybe. Canary properties of undefined in color 89. Right, because at the very end of the program, it will be, like, we only want to do this if there actually is one. -1 means it didn't find anything. Or if not, -1, yes. that's an answer. Does that make sense? So 0 will be 0. And then it's connected to 4. Which I guess is this one. That's a 1. Good. 4 is connected to 5. 5 is 0. Good. And then 1 is going to be 0. It's connected to 3, which is a 1. And then also 1 is connected to 2, which is also a 1. Yeah. These are not connected, and these are connected. I think that is an answer. And I think it generalizes, I hope. Maybe we'll find some other contract. But that's not true. But rolling the noodles. Pipe. Ramen noodles. Okay. One contract. $500 mil in the bag. Let's go. Success. And I'm pretty sure I can reuse that code to just solve any of these if we see it again. There is like the contracts API. What is it? Contract. Coding contract. It's like just explain, but I swear there's definitely, what was I looking at? Fact. This. There we go. So the coding contract API, you can like automatically attempt. I don't think we're there yet because we only have 2 solutions. Yes, I did. Yeah. So here's more contracts. Okay. Yeah, so we can like remotely attempt them. You can create a dummy contract. So why don't we could try that actually. Create dummy contract. Type of contract. So contracts do have a type. Did it? I'm assuming this disappeared, right? Let's go do this. Yeah, it's gone. No, it had 2 contracts on it, actually. It didn't change. Yes. But you can generate contracts with a type. So we could test our program just for fun. Let's just do /gen contract. We can do contract .gen create contract. You do have to pass in the type. I guess, I don't know if it's spoilers, but I guess, I mean, it's not spoilers if we're using the API, right? We're hacking. Contract. I see. So in the future, when we get these contracts, we can just get its type and then route it to our solution function based on the type. Just select it. So here's the contract types. Let's get the tail. material. Oh, we could. You're saying like label the ones that we've solved? Hmm. What do you mean both? As in like actually solve them dynamically? Or, oh, I see, just like sort them. Yeah, we can do that. I just, in this one, I want to try creating a dummy one. And also just see what the types are. Holy crap, I think there's a lot. Line. We got some work to do. So we did two. We did, what did we do? Proper two coloring of a graph. And it was like something square, veneer square or something. This one, encryption 2, visionaire cipher. Wow, we went straight to encryption 2. Not even encryption 1. Sweet. So, cool. Yeah, let's label the auto shopper. Yeah, I guess we could start auto shopping. There's nothing we're really saving up for, right? And I guess we might as well spend the money. Sure. Let's do that. The auto hacknet. And watch that. Just go downwards. Here, I'll give it. Oh, sure. Join the net burners. Buy a couple nodes for them. He will just auto shop the upgrades. Very nice. Okay. So I guess we'll just have an array of like the ones that we've solved, right? And that is, oh, it's this one. Maybe there must be like an enum or something, right? Surely. Yes. We got this one. And we also have encryption too. Yeah. Cool. And I guess we can do like solvable traits. And or actually, well, sure. We can do unsolved. It'd be cool to also add the type, like the location of the server, and then also what type, because then we'll want to prioritize the most common one, right? So mm, okay, I guess I pick this. Okay, I don't want that. Okay, let's just find the thing. Um, yeah, we should just do. Should do the name stuff here. The end. Or this is just the name, right? Technically. How do we get the actual details? This is file name. Get contract. Okay. Like, sure. Okay. Mm, name this to names. Or it's contracts. Get contract, file name on the host. Host is this. Host names. Fine. So we got the details. If C type, right? Yeah. So I guess we want this. This is like contains or something. Fine. Is valid with first element and undefined otherwise. Okay, cool. So that should work. If that, we will append it to solvable. Does it have like a name description? I don't think it has that. Hmm. so it's the input. Compound. I don't have the names though. It's kind of annoying. I want to make like a tuple. I guess I could just have like two arrays with the same length. Feels kind of gross. Oh well. File name. This. Okay. Uh, so I'll do that. Just do file. Not files, right? What do we do? Server file names. Delete that. File name. And the host name. I guess we want the or we could do like yeah, they're probably the config type. Maybe we lead with like true or something. Yeah. Okay, let's just try that. Syntax error. error. Coding contract name is not defined. So I have to like import it. Or something. Where's my error? Line 3 column. Oh, line 3. Nice. Okay, let's see. Hmm. Oh. Maybe like s dot renums. Great. Shortest path in a grid is not 26. That. Else is not declared. Group. Line is not defined. Okay, I don't think I need that, right? Sweet. Well, it didn't work. But we did get the type. Version 2. Here's some. Oh, is this because it has this weird... The other thing work? No, this has to. Okay, well, we can save that for another time. Pretty sweet. We can find a bunch of contracts. We've solved 2 of them. Yeah, we'll be pleased. Let's just stop going to this gym and instead do some crime. this one? 4.5 million. That seems pretty legit. There we go. And this is auto spending. Do we want it to keep auto spending? I guess it's fine. Oh, actually, everything's max level. What the heck? Well, it's fine. I guess cores. It can still do cores. Yeah. So it's leveling up the cores. That's fine. And I guess the script doesn't support buying new nodes yet, actually. So maybe that is something we can improve on next time. All right. Peace. When should I buy new nodes? I mean, probably buying new nodes should just be considered in like when it picks like the cheapest thing to do. Like one of the options should always just be to buy an extra node. All right, bye.